In this video, you will learn how to solve collision problems using the conservation of momentum. The conservation of momentum says that the total momentum before a collision equals the total momentum after a collision if there is no external net force on the system. In other words, it's an isolated system. As I read this question, I'll be filling out the chart below to help us organize the information. Tim, who has a mass of 64.9 kilograms, is moving at 14 meters per second on his skateboard. He catches up to Victor, 70.7 kilograms, who is directly in front of him, moving at 10.8 meters per second. Tim jumps onto Victor's back and to continue to move forward. What is their speed immediately after the collision? So we need to first remember that momentum, the equation for momentum, is mass times velocity. Next, we will sketch Tim and Victor. I'm going to use this box to represent Tim, and then this box to represent Victor. Tim has a velocity that we will label it Vt for Tim, and then Victor is going to have a velocity. We'll label that V for Victor. Afterwards, they collide and they are traveling together with the velocity, which we'll call Vf. Okay, so what we're going to do is we're going to find the momentum of Tim before the collision, which is going to be the mass of Tim, 64.9, times the velocity of Tim, 14, and we get 909 kilograms meters per second. And then Victor has a mass of 70.7 and a speed of 10.8, and so his initial momentum is 764 kilograms meters per second. Afterwards, Tim is going to have a velocity of 64.9 times Vf, which is what we're looking, and Tim will have a momentum of 70.7 Vf, which is what we're looking for. Now down here, we're going to add up all the momentum before the collision. 909 plus 764 is equal to all the momentum after the collision, which is 64.9 plus 70.7 Vf, and Vf over here. Okay, now we can factor out the Vf, and then so on the left hand side, if we add up 909 plus 764, we get 1673 is equal to, on the right hand side, if we add those two numbers up, we get 135.6 Vf. I'm going to divide both sides by 135.6, and Vf we get, and I'm going to flip it around, Vf we get 12.3 meters per second. Okay, so what we did here was we figured out what the initial momentum of Tim was, and Victor, we added those two numbers and we got 1673. Then we added up the momentum of Tim and Victor after the collision, but we do have this unknown variable, this final velocity. We added them up and we got 135.6. That was the on the right hand side times Vf, and then we solve for Vf to find the final velocity. Now let's take a look at another problem. A railroad car, 15,200 kilograms, is moving with the speed of 2.31 meters per second, collides with a two-car combination moving the same direction at 1.25 meters per second. What is the speed of the three couple cars after the collision? So we've got a one-car system that's moving, and we have a two-car system that's moving, and then they're going to collide, and all three of them are moving together. What is that final velocity? So I'm going to, first row, I'm going to write down the information for the one-car system, and then second row will be for the two-car system. I'm going to do mass times velocity, 15,200 times 2.31, and I get 35,112 kilograms meters per second. And then for the two-car system, it's going to be they're going to have the same mass, so it's going to be 30,400 times 1.25, not going as fast, and the total momentum there will be 38,000 kilograms meters per second. After the collision, the one car will have a momentum of 15,200 VF. The two car system will have a total momentum of 30,400 VF. Okay, so the next step is to add up all the momentum before the collision, and I'm going to write this down so you know how I'm getting this number. So we have 35,112 plus 38,000 is equal to, on the right hand side, I have 15,200 VF plus 30,400 VF. I'm going to add the number on the left hand side and I get 73,112. Right hand side I get 45,600 VF. I'm going to divide 45,600 on both sides. I'm going to switch the sides and I get VF equals 1.6 meters per second. So once again, what I did here was I figured out the initial momentum of the one car and also of the two car. I added those up. I got 73,112. And then I also added up the final momentum of the one car and the two car system. And I got, when I added those numbers up, I got 45,600 VF. I solved for VF and got 1.6 meters per second. Previously, we looked at two hit and stick problems where the objects collided and stuck together. Now we'll look at a problem where the two objects collide and they bounce off, they don't stick. A 168 kilogram red bumper car moving east at 2.7 meters per second collides with a 134 kilogram blue car which is at rest. After the collision, the red car is moving east at 1.18 meters per second. What is the speed of the blue car? So here we have a red car initially moving at 2.7 meters per second. Then we have a blue cart not moving. And then afterwards, the red cart is moving not as fast, 1.18 meters per second. And the blue cart now is moving, and we're looking for that. We'll call that VF. So our two objects here is the red cart and the blue cart. We want to first find the momentum of the red cart, which is 168 times 2.7, and we get 453.6. The blue cart has no momentum because the blue cart is not moving. The red cart, after the collision, has a momentum of 168 times 1.18, which is 198. And the blue cart, after the collision, has a momentum of 134 times VF. And we're looking for VF. So now we're going to add the total momentum on the left-hand side, which is 553.6 plus 0 equals, on the right-hand side, we have 198 plus 134 VF. We're going to subtract 198 on both sides. Subtract 198 on both sides, and we get 255.6 on the left, and then on the right we get 134 VF. Divide both sides by 134 and VF, we get 1.91 meters per second. Okay, so what we did here was we first calculated the momentum of the red car and the blue car before the collision. That was collision. We added those numbers up and we got this number. And on the right hand side, we calculated the momentum of the red car after the momentum, and then the blue cart. We added those two numbers up and we got this right here, and we're solving for VF, and we get 1.91 meters per second.